if I use this in multiple threads, it's very possible that this will fail. Now, it really depends. Getting this to fail is tough. If I wanted to get it to fail to prove to you that it would fail, it might fail the first time. When I was teaching this class 2 weeks ago in Houston, I couldn't get it to fail. I ran it 10, 15 times in a row. I could not get it to fail. I jacked up the threads to 1,000. From 2 to 1,000, I increased the number of iterations to a huge extent. I just could not get it to fail. What I ended up doing is I changed it a little bit and put in thread yields, and I was able to force it to fail. But it took a lot of effort to prove that, in fact, this code was incorrect. All right? So how do we fix this? There's 2 options, client and server-based locking. The client is who's using the class, and the server is who's operating up the service. So in this case, the service would be the iterator, and the client would be the thing using the iterator. All right? So I'm just using terminology from somebody else. Here's an example of client-based locking. While true, I'm going to synchronize on the iterator. Now, as long as everybody uses that same synchronization, if someone wants to come in here and calls iterator.hasNext without using the synchronized iterator, they're going to get in all the time. So it doesn't actually solve the problem. Everybody that does a client has to agree to lock on the same thing. All right? But I can do this, and if everybody guarantees that they lock on the same thing, then this will work, right? Because I make sure I haven't got a next, that I have a next, and if so, I get it, otherwise I break. And presumably there'll be processing in there and so on. So client-side locking is the client does the work. This works. This will work every time. It'll give you correct results. Problems?
Well, there's no way to enforce that all the clients will obey this.
It's about enforcement, right? What have you just done? You have taken something that inherently causes capital V very, capital H hard, capital P problems, very hard problems. Like truth, capital T versus lowercase truth, or capital L leadership. Multi-threading introduces, I'm just saying, there's a difference when you put in a capital letter versus a lowercase letter. If I talk about leadership, lowercase L, you're manipulating and such. When I talk about capital L leadership, you're accountable. Very hard problems are really nasty problems that probably aren't going to cause you problems until you're in production. Right? You said you had a production problem, right? Didn't happen on the machines, right? Happened in production. And how much hell was raised? Someone got beeped on a beeper, I'm guessing.
No.
It wasn't that bad?
No, but they had to restart the reservation processing application 3 times during the business day. So people at Hertz counters all over the country couldn't make reservations for about 5 minutes 3 times during that day.
That's not a big deal. Really, it takes so long to type in all that information. It's an extra 5 minutes.
Well, and it's restarted your reservoir in the middle of
and of course, restarting the machine is going to solve a synchronization
restarting
problem.
the active ear.
Restarting the ear is going to solve a synchronization problem. I don't buy it.
That wasn't a synchronization.
Oh, that wasn't
That was
synchronization.
a propulsion.
Okay, that's cool. Okay. So there's still a problem. It's just restarting happens to make it go away for a while.
Now, Avis is going to take this off of YouTube and make a commercial.
Oh, good.
Okay, so this is client-side logging. It certainly works, but someone's going to copy and paste this code, and then they're going to get it wrong. This is not a good solution, but it does work.
So just to illustrate exactly, if a whole bunch of classes use synchronize on the iterator, and me as a novice programmer, I make my own separate class, and I decide to use the iterator and synchronize on the collection.
Let's say you don't
synchronize.
synchronize on anything.
Yeah, I just call them as next innocently.
You're not.
I break all of these guys.
Yes, you potentially break everybody else. Yeah. That's right. So all of a sudden, all your good intentions went to hell.
So your beeper doesn't go off.
Okay, so now let's talk about server-side locking. Okay, but I want to go back one point. Notice the client code changed. All right, the client code has to change here for this to work. Okay, I'm going to suggest though, just like we have that increment and get on the atomic variable, on the atomic integer, get next or null. So notice I've just taken the doesn't have a next, get the value, otherwise return null. And the returning null is how a client knows that I'm done. So the 2 methods are now one method, it's atomic, synchronized, right? Synchronized and it's atomic. And then I return back null, and so the client has to change again. But now the client looks like this. While true, get the next, if it's null, break, otherwise do my processing. I've taken that shared state, that locking, instead of putting it out in the client and therefore replicated and problematic, and I've hidden it behind a firewall. All right, this is called protected variation or encapsulation. I'm just keeping the state of my multi-threadedness as close in as possible and not exposing it to anybody else. Now, it turns out I could have also, in this case, used an atomic integer and not blocked. But notice in both situations, I'm putting the semantics on the class that has the semantics rather than forcing clients to do the work. That's the way to go, always. All right, that's the way to go, always. And then, I'm going from synchronized to the atomic integer, so it's faster. But, remember, get it to work. Get it to work right. That's using synchronized. And then going back and using the atomic integer, maybe getting it to work fast. The atomic integer is one of those, I would call it free optimizations. It's pretty clear. It has well-defined semantics. If you're using Java 1.5, it's great. So it doesn't really, I would use it if I need to keep a
and
counter.
You can completely use it anywhere you want to use an integer, right?
Yeah, exactly. As soon as I have to start using synchronized, the atomic integer it's much faster. It's always, I'm pretty sure it's always faster. It's just a matter of how much faster. Is it 3 times faster or is it 20 times faster? But it's always faster, even with those method calls. All right? Because it turns out that probably that class isn't subclass, and so the actual method calls can be not virtually dispatched by the just-in-time compiler and possibly even inline. So underneath the covers, it looks like a method call. When the just-in-time compiler is warmed up, isn't costing you anything because there's no method call, which is pretty cool. From your perspective, what you notice is, wow, that's fast, and it worked. But you should all read the JVM specification. It's a good read. I have. It's not a good read. I lied. Okay, so if you have control, you should prefer server-side. You're not repeating code. You're not duplicating it. It's going to change your client API, but it changes it either way. But here's an observation. The iterator, again, the iterator interface is inherently not thread safe. You could counter and say, well Brett, what you're doing is really traditionally iterating, because iterating tends to go from one end to the other. But in my experience, most of the time you're iterating, you want to apply to all, but you don't really care about the order. So I would counter by saying, most of the time you really don't want an iterator. You're just using an iterator because that's what Java says you should use. Honestly, a better approach would be, again, and we've talked about this in other jugs, using closures, and then underneath the covers, if it wants to multi-thread its own business. But that's for Java 1.8 or 1.9 or something like that. All right. Question? Sorry. Now, you might argue, what if I don't have control of the class? Okay. What if you don't have control? Well, that's fine. What you do is you adapt the underlying thing that's inherently not multi-thread safe. You make it so that it's server-side locking from the adapter perspective, and then over time you move everybody to the adapter. All right? You've heard this before. Every problem in computer science can be solved by adding a level of indirection between you and the problem, except for the problem of too many levels of indirection. Subnote, even that can be solved because you can have a cheating level, but whatever. Right? So I got a problem. This thing is not multi-thread safe. I'm going to put a wall between me and it, and then I want to make sure that everybody uses that wall. Right? Questions? Now, I wasn't confident enough to know that there's absolutely no situation in which it's not possible. But I probably should be a little more aggressive and challenge people to prove me wrong.
I work in a dysfunctional shop. If you work in a dysfunctional shop,
if you have religious problems,
how's about that's a good point. In fact, gosh, I've had this conversation. We had this conversation. I had this with Bob, and we came to the conclusion which should never technically be possible, which is technically never, but socially. Good point. But the thing is, if you're in a dysfunctional shop, then you don't have to block. We already decided that, right?
that's true.
Because your code's not going to work anyway, so who cares? Might as well be fast and not working rather than slower and not working. Well, it doesn't really matter, does it? If you have no requirements to satisfy, any solution will suffice. And if I work in a dysfunctional shop, anyone gonna want to argue that one? Okay. Okay, now, I'll quickly go through this again. You guys have seen this at lunchtime, but some of you have not. We're going to look at another new feature of Java 5, but we're going to get there through a few steps. First of all, here is a server. Forever. Accept a connection from a server socket, get the message, process it. Over and over again. All I do is I'm a server. I'm waiting for someone to communicate. I get the message, I process it, I send back a response, and then I get the next request, process it, send back a next response. A server socket. How many of you are familiar with sockets, socket programming? Most of you, not all of you. A socket is just actually a two-way connection between two machines. You can write to it and read from it, write to it and read from it. So it's a two-way connection. And a server socket, what happens is I try to connect to a remote machine on a server socket at a known person. The machines agree, okay, well, you're connected to me, but now I want you to use port 16,000 instead of the known port. You're going to use 32.762, and so on. And so when a connection comes in, once I've actually formed a connection via a server socket underneath the covers, my actual connection is on a different socket, but that's all part of the protocol. You never see that. So I connected a known port. The actual communication happens at another port, but you don't care about it. So a server socket is a really quick way to do a server. So I just sit there and accept requests. If I wanted to write a client to connect to this, here's an example. I'm going to connect to the known port on my machine here. I'm going to send a message, give the message, and then close the socket. Simple enough. That right there, these two things. If I had this running on a Java process on a machine in Hawaii, or some other place you want to go, Hawaii sounds pretty good this time of year. I can run this machine, connect to that machine on the port, and assuming firewalls were in the way, I've just done remote communications. It's very easy to do. I've done this. Anyone written code like this before? I've actually written production code that did exactly this. In fact, one of the very first things, the very first professional application I was paid for in 1997 using Java 1, we effectively threw an applet into IE 4, Java 1.02, and you know what that applet did? When you connect it to a part of the DOM, like a pull-down list, it would look at that activity, and then it would go to the back-end server using this kind of code, get the information from the next thing, and update the DOM so that rather than having to resubmit and re-get the whole thing, it would update the next subsequent entry. Now, does that sound like anything you've ever heard of before? Exactly, 1997. Using this exact code. The only difference was in 105, in 102, I didn't have object serialization, so I used strings and integers just encoded. But to go from that to when we upgraded the browser to Java 1.1 using object serialization, it turned out we had to change 2 lines in 1 class because we hid it all behind an interface, or behind a single class. But the bottom line is, I've done this on multiple times. Before that, I actually worked on another application with Java phones in 1997 that didn't actually go anywhere. But a phone running the Java VM. You might have heard of this. Back in 97, it was actually like a huge deal. Now it's like, what game am I playing in Java on my phone? Okay, this doesn't have a JVM, but I bet you your phones do. So this is standard client-server stuff. Problem is, it's single-threaded. So how long does this take? However long it takes to accept, get a message, and process it, that's as fast as it can possibly respond. If this process takes 5 seconds, everybody else waits for 5 seconds. Single-threaded server. Maybe that's good enough, actually. It might be fine. It turns out, how many of you have heard of Ruby on Rails? It turns out Ruby on Rails is single-threaded. Now, there are adapters you can throw in front of it that fix that problem, but Ruby on Rails, inherently underneath the covers, is single-threaded. I didn't know this. I just found this out recently. So it looks sort of like this. A bunch of requests come into a server socket, and then they get processed one at a time. That's it. Here is an example of threading it. I'm going to start a socket. Sorry, I'm going to start a thread, process it. Right there, I start a new thread. And so the time that this takes is from the accept to sending start. I have to accept, create an instance of a thread, start, and start pretty much happens right away. It's changing the state of a thread. So now I can handle any number of client requests in theory. The response time on this is much faster. It's only as long as it takes to accept and start a thread. The process does something, doesn't really matter what it does. I put a thread sleep in there in this example. In the class environment, I give them a project, and then there's a unit test. And the unit test fails if it doesn't process 10 requests in 10 seconds. And the way I do that is in JUnit 4, I can say app test expected equals 10,000 milliseconds. And then the unit test fails. But as soon as you do this, all of a sudden, the unit test takes 1.2 seconds to run. Because even though you're wasting a second sleeping, that sleeping is all happening at pretty much the same time. So there's very little overall overhead. And as a result, the test that failed to finish in 10 seconds, now with this runs in 1.1 seconds, which is a pretty impressive response. You get rid of 87% of the overhead just like that. All right, and this looks sort of more like that. The requests come in. I start a bunch of requests, and when they finish, they come out. Now, it's actually oversimplified because 1 could start, then 2 could start, then 1 could finish, 3 could start, 3 could finish, 4 could start, 2 could finish, and 4. I mean, the ordering is not nearly as clean as that. But the bottom line is, as long as I'm not CPU bound, I can't increase my concurrency. All right. So when you're looking at threading, you have to understand the difference between I/O bound and CPU bound. If I've got a lot of I/O, I'm hitting a database, I'm reading any kind of file, system out. Not a good example, but system out is an example.
Downloading a web page.
Downloading a web page. I'm thinking hitting a queue. I/O bound. You can increase your concurrency with I/O bound stuff. If I'm, for example, I've got a whole web page and I'm using a regular expression to parse out individual lines, and it takes a half a second to do that. You know what? A half a second is how long it's going to take, and adding 2 threads is not going to speed it up. In fact, it's going to slow it down. All right. So I/O bound stuff, you can increase your concurrency. CPU bound stuff, not so much, unless you have multiple processors and your JVM supports it. If I have a 4-core system and my JVM supports it, I can start 4 threads for CPU bound stuff and actually get some whatever performance boost. It wouldn't be 4x. It'd be 3, 2.5, 3, 4, 3x maybe, but it would be an improvement in performance. But you're sort of at the mercy of your VM. Okay, now, here's a problem with that. First of all, creating a thread is expensive. Object creation, honestly, as Java's gotten on in years, object creation is a lot less expensive. In fact, in Java 1.6, if I create a variable as a local variable, if I create an object and store it in a local variable, and then that object goes away outside the method, sort of like C++, but not quite as much, that object doesn't really get into the same part of the heap as other objects, and it gets reclaimed much faster. In fact, you know the old adage of setting values to null? In this situation, it's actually less efficient to set it to null than it is to just let it fall out, because the garbage collection takes that into consideration. It's one of those optimizations. So garbage collection in Java 1.6 is substantially improved over 1.5. Okay, so but creating threads is still pretty expensive, it turns out, because you got thread locals and it might be scheduled and all that kind of stuff. Also, how many threads do you think your VM can handle? How many? Okay, that's a theoretical limit because it's represented with 16 bits. But how many in practice can you handle?
5 months to find out.
Yeah, a few. You know, I've actually on my Mac, I've created an application that had like 1,000, 2,000 threads, and sure enough, they get created. But if you actually look at how much work is getting done, at some point, you know, you're getting maybe a little more done, and then boom, you start just getting context switches. It's thrashing. You're going to have that's something you have to experiment with. Generally speaking, you want to pool your threads and control that and do performance tuning based on the actual deployment environment. But it's certainly not 1,000 most of the time. There are some machines that support thousands of threads. For the most part, 10, 20, 30, you know, it depends.
Azul.
Azul?
That Azul box that they presented to us.
Oh, yeah. Yeah, that has a lot of thread support. Turns out my Mac's not like that.
No.
It's not bad, but it's not like that. Okay, so let me show you an alternative. This accomplishes the same thing. So if I had to set a unit test, which I do, that verify the behavior from a, say, performance standpoint, this performs maybe a touch slower than the previous one. But over time, it would perform probably the same or faster because I'm not creating threads. This is a new class of Java 1.5. It's called the executor. So in this case, the executor service. But there's two interfaces. There's executor, and then there's executor service. Executor is just a fairly simple interface. Allows you to throw runnables off to a queue, and then at some point they get processed by a thread pool. Executor service gives you a little more functionality, and we'll be looking at that. I happen to use executor service here, but I'm not doing anything that's specific to executor service. So I create a thread pool. How many threads do you think is in that pool?
50.
50, yeah. This actually, executors is a factory. That's a factory method. And there's lots of different factory methods. It has a lot of configuration. You can have it start with a certain number and grow and shrink. You can have it reclaim threads if they've been unbusy for a certain number of milliseconds. You can set the policy on what to do with threads that throw exceptions. You can set fairness or not fairness. Not with the executor service, that's something else. But there's a lot of configuration with the executor service. This is just scratching the surface. There's even an interesting configuration where if I'm using all the threads, they're all busy, and a new request comes in, that new request actually gets executed in the thread that called it, and thereby actually throttling the addition of new tasks onto the executor service. Or I can say, well, if the thread pool is busy, reject it. So it's a very configurable thing. Down here, I give it a runnable. At some point in the future, that runnable gets put on a queue. And I've got these threads over here. This thread pulls it off the queue, starts executing it. The next thread pulls it off the queue, starts executing it, and so on. And the threads are pooled, so I don't have to worry about creating threads and so on. I get rid of the overhead of creating threads. If a thread dies, the executor service will recreate the threads. It's all built in the Java 1.5, and it's really simple to use. I mean, how many times have you needed something like this in your systems? Yeah, once or twice. Now, as Ryan pointed out at lunch, Jakarta Commons has had a thread pool for a while. This is, I don't know that it's based on the Jakarta stuff, but it probably has all the features of the Jakarta stuff and a little bit more. Or certainly it's usable. I never used it.
I bet Doug Lee had something to do with writing it.
I think it came from Doug Lee's.
It might, I wouldn't be surprised, because a lot of the stuff is from Doug Lee. His work is great. For those of you who don't know, concurrent programming in Java by Doug Lee, prior to Java 5, was the only book you needed on, in my opinion, on threads in Java. In theory, he's got a new version of that book due out, but it's they're supposed to come out in May, and I'd love to see it. And as soon as that book comes out, I'll get it and read it, because I've read another book, a really pretty good book, Java Concurrency in Practice, and I like the book. It's a good book. I read it cover to cover. I've marked the hell out of it. It's a great book. For some reason, and I can't. This is sort of an intuitive thing. The Doug Lee book, when I read it, seemed to go deeper in different ways. Where the Java Concurrency in Practice sort of abstracts the model and sort of takes you through that abstraction, Doug Lee sort of takes it maybe from more of a computer science bent. And since I have a computer science background, maybe it spoke to me better. But Java Concurrency in Practice, great book. It's the book we give out when we teach the class. And I definitely recommend it. I want to see the Doug Lee book for a comparison. But it doesn't have Java 5 stuff in it. The current one doesn't. So the executive service gives you a thread pool in this particular case. Cool? Any questions about that?
What does client handler look like?
I'm sorry, what?
What does client handler look like?
Client handler. Okay, so client handler.
Is it runnable?
Yeah, it's a runnable. All client handler is it takes given a socket, it reads the message, processes the message, and sends it back. It's those lines of code. It has 3 lines of code. Read the message, sleep 1 second, and then process the message.
Okay.
You want
execute isn't accepting client handler; it's accepting runnable.
And client handler happens to be runnable. Exactly. So in fact, maybe to make this a little more, I wanted to get this as short as possible, but I could have just as easily done new runnable blah and then passed them in there. That would have been fine. And in fact, the first time I was using it, that's what I did. Other questions? Okay, now we're going to talk about futures. How many of you have used futures? How many of you have a future? It's a good question. Just don't know. Okay, so a future. Runnables don't have results. Run has a void return type, doesn't take exceptions. This has always been a limitation of run. If you want to get the result of a runnable, either you held on to the instance of runnable and it wrote to a local variable, I mean an attribute, or it wrote to a variable that was in the context in which it was created, or you passed in something, but it wasn't very direct. All right? It had some kind of side effect and you'd have to figure out what was going on. Well, they've introduced a new interface, callable. Callable has a single method, call. It can return back anything. It's a generic type. It uses generics. So in this case, I've got a callable of a string. It could have been a callable of an object. Let's say I don't want to return anything. It could be a callable of capital V void. You know about that class? The void class? Yeah, it's not very useful, but anyway, I created call and exception. Now, it turns out that whereas before I said execute, now I'm submitting. The difference between execute and submit returns something. Execute just takes it, puts it on the queue. Submit takes it, puts it on the queue, and gives you back a token in the form of a future. And at some point down the road, I can say, hey, future, get. And until that task has executed and returned a result, I'm going to block. I can also ask, are you done? And if an exception got thrown, I can figure out the exception that got thrown. So I can actually put something on a work queue, go about my business, and then when I get to the point where I can no longer continue, I'll just do a future.get, and then I'll wait until that future finishes, and I continue processing. That's all a future is. So a future is a guaranteed, well, a result that hopefully will come in the future. You could get deadlocked. It might just be that you never, the thing never gets processed. It could throw an exception or something like that. But the bottom line is, in the happy path situation, at some point in the future, you're going to get a result. And if I do a .get and it's already there, I get it right away. I'm blocking. Otherwise, I block. And if that thing gets interrupted, I can get interrupted and all that kind of stuff. Questions about that? Okay, now here's an example of using it. This is a contrived example. But nonetheless, here it is. So let's just say I'm going to, first of all, have the processing right here. So I get the message and I process it. And then the result of processing is what I return. I submit this. And then in another callable, I wait for the future to be available. I send the message and then I return null. I probably should have just done a runnable here. I could have submitted a runnable, but I didn't. So I used callable 2 times there. So notice I've just broken that bigger task up into 2 smaller tasks. Get and process the message, and actually send the message back. This is an artificial separation. Questions about that? Have any of you ever had a need to use features in your stuff? Okay, so there you go.
Before 1.5, I implemented it, but didn't know what it was.
Yeah. Have you actually used this in 1.5?
No.
Will you consider using it now? If you
I
haven't
think it would have been a lot cleaner than my solution.
Well, you know, you have to roll your own. I mean, sometimes features are exactly what you need, right? There's a certain style of programming, and I mentioned this at lunchtime. Some of the Xerox printers have an operating system, and those operating systems are really good at just having huge queues of tasks to be executed. Now, there's a little bit of a difference there because those tasks are non-blocking, and we'll talk about that in a second. But what happens is a task oftentimes will generate another task on the queue, or will put itself back on the queue. So what happens is a task, it says, oh, it's my turn. Is what I need to have done ready? Oh, no? Okay, well, I'll put myself back on the queue. You ready? No, put myself back on the queue. So it's sort of like a busy wait, and the tasks keep getting added on. For some solutions or some problems, that's exactly what you need to do.
I guess I'm thinking about the question at the bottom of the slide. And it seems like that would be good for that sort of a handoff. One task I had to do once was to go get something from one web service, run another web service on it, and then submit it back to the first web service again. And so there was like 3 stages. And when I did it single threaded, it took a lot longer than having one thing that kept getting things off the first web service, and another one that kept running it on the second one, and a third one that put it back onto the first web service when it was again. So I did it more in a stage event-driven way. That's why I might want separate thread pools.
Was it faster?
Yeah. Because they were all 3 were IO.
They were IO bound, but weren't they dependent, or were they not dependent? The gets were not dependent. Then you merge the results and send them back. See, because if I've got 3 things I need to perform, and this one has to follow, this one has to follow this one, and this one has to follow this one, separating it out.
I just got queues in between.
Well, yes. What that could do is improve your responsiveness.
Yeah.
But
No,
I'm sorry, your
the same
concurrency. So they were independent. At
You
some
could
point.
go get a bunch from the first web service.
I got you.
And whenever each one finishes, it can start in the next phase.
So I got it. So I had multiple requests from Service 1.
Yeah.
And I could start processing as soon as some of those were
As
available.
soon as each one came finished. Yeah.
Got it. Okay,
That's
yeah.
why you might want separate thread pools, right? Or
No,
put it
no,
back.
you can you can have separate thread pools if you decide you want to set priorities, different priorities.
Okay. So separate thread pools doesn't make any difference.
It might not. It really depends on the situation. Here's a danger. Well, I'll show you a danger coming up that might cause deadlock. Because if you use the same thread pool, and even if you use a separate thread pool, if I've got something in this thread pool waiting on something to finish in another thread pool, and those pools get filled, it's possible for deadlock. There are 4 conditions. What's deadlock? Define it for me.
2 locks are mutually exclusive, so both locks are waiting before they unlock, but
And they will never give up, right? And so technically, deadlock will never exit. And in fact, in Java, there's no way, from a language perspective, to terminate deadlock other than killing your VM. In a database, they understand about the possibility of deadlock, and they are able to forcefully release locks. But in Java, there's no guaranteed way to release a lock. You might think, well, there's this method thread.stop, and thread.stop. But thread.stop can terminate a thread, and the locks are never released. And so just because you've terminated a thread doesn't necessarily mean you've released the locks. Now, that's sort of VM specific, but according to the Java memory model, that's what's going to happen. And so in Java, deadlock is permanent. Those intrinsic locks, as soon as I've got a lock, I don't release them unless I leave my block properly. But if I get terminated, I don't necessarily release them. And deadlock, right? And live lock is sort of the exact opposite. I try to do something, I can't do it, so I go to sleep, and then someone else tries to do something. And there's something that prevents either one of us from getting it. So we wake up, go to sleep, wake up, go to sleep, and we just sort of keep going. It's actually hard to get live lock in preemptive multi-threaded environments. When you do simulators where each thing is given a time block and such, that's a possibility. You can have short-term live lock, but that's not live lock.